Oh, it is recording. Sorry, everyone. I might be a little off because someone in my fourth hour, whatever you did at the end of fourth hour, you know who you are, and I don't appreciate it. Okay. There might be some technical difficulties still because of, again, we're on Zoom, which is it's just a little tougher for these recordings, but so sorry for any technical hiccups. I'm doing this between hours. Um, okay, so let's think of an actual 8 by 11 piece of paper, which this started as 8 by 11. Zoom in on the video if you need to, that top part with me. I cut corners out of this box. Okay. I cut corners out of a piece of paper in order to make a box. I had to cut two corners from each side. Okay. One of the sides of the box sides of the piece of paper is 8 inches. The other one is 11. So I have to take two corners away from each side, right? So I'm taking my 11 side and I'm going 11 minus 2x. X is just represented for however big that cut you make is. And then the other side, 8, that's where the 8 minus 2x is. Now, if I cut a 2-inch piece out of this corner, this would be a 2-inch tall box. If I cut a 3-inch corner, then this would be a 3-inch tall box. In other words, the height, the third dimension matches whatever you cut out. Therefore, it is x. Now, what is a reasonable domain for this context? This means like how much could you actually take away from this piece of paper? You can only take away up to half of the smallest side. So basically, how do we say that the most we can cut is half of 8, aka 4. But we actually have to cut less than that, right? So our cut needs to be smaller than 4 inches. And in order for us to actually have a third dimension for this box, we need to cut it at all, right? We need some sort of height, so we can't have 0. So our cut needs to be greater than 0. So we must, and it needs to be less than 4 because the two things that we have to make sure are true. The most we can cut is half of 8, half of the smallest side. And the smallest cut has to be more than nothing, right? So that's in mathematical terms, 0 is less than x is less than 4. What that means is we have to actually cut a corner to make a box, but that corner can't be so big that none of the paper exists anymore to do another cut out of the other side. Now, this is the part where the technical difficulties tend to happen. That's when I switch slides. So we'll just make small talk. It's really hard for me to do this in a good mood after somebody did what they did after fourth hour. Ooh. Okay, box method of distribution. Basically, the box method is distribution. Okay. I'm distributing x minus 1. I'm multiplying it by x squared. I'm multiplying it by negative 4x. I'm also multiplying it by 1. Now, a lot of people are doing this well. Multiply those to get x to the third power, then negative x squared. That's negative 1 times x squared. Negative 4x times x gives me negative 4x to the second power. Negative 4x times negative 1. That would be positive 4x. And then x times 1 is 1x. If you want to write the 1, you can, or you can just write x. Negative 1 times 1 is negative 1. Now, a lot of people are doing this box well, but then not combining your like terms. Remember, you need to combine these boxes that are lining up here. So coming out of this box, you should get x to the third power minus 5x squared, because negative 4x squared minus x squared will be negative 5x. Then 4x plus 1 is going to give us positive 5x. And my constant, aka the y-intercept, negative 1. Okay. So the lead coefficient ends up being 1. This. And if I hit clear all, it takes away all of the slides. I found that out the hard way when doing my Algebra 1 video the other day. That was fun. Okay. What is true about this? Is the degree odd? Well, if it were odd, it would either go up and down or down then up. This is doing opposite, right? The dance that I'm doing, it's going opposite. So yes, the degree is odd because we're going opposite. If it's odd, it's not going to be even, so that can't be true. Constant term is positive. A lot of people are confusing constant term with lead coefficient. In this case, it's kind of confusing because both are positive, right? Constant, the lead coefficient is positive. That's why I'm going up. But this is saying constant term, aka the y-intercept. The y-intercept here is 0, 3. Therefore, the constant has to be positive. Even if you didn't know that the constant was positive, you might have accidentally got that one right. But be careful. Constant term is talking about the y-intercept. The graph does not have a relative minimum. Well, relative minimum is the bottom of those dips in the middle of here. So that is a relative minimum. Therefore, that's not true. Multiplicity of the 0x equals negative 3 must be even. Well, if it were even, it would bounce. Let's see what happens at negative 3. We cross. If that crosses, that means that is odd. Therefore, that's not true. The graph has a relative maximum. So let's take that definition of relative minimum, the bottom of those middle dips, and let's look at, is there a top of these dips? Well, that's this. Yes, this is true. Why is it true? You can just draw an arrow there. Show that that is a relative maximum. In the comments below, tell me what you're being for Halloween. I'm being Coach from The Gentleman. I'm also being Magnum PI. The men of math are being Magnum PI. The old Tom Selleck show. So you'll see that on Thursday. You show up, and I'll show you a picture of my other Halloween costume. I'm not sure why the bottom of my graph isn't showing up. Maybe by the time I'm done writing this problem, it will be there. Fingers crossed. All right, what is the leading coefficient and degree of this? So in front of all of these x's, there is an imaginary 1. And in front of this negative, or I guess behind this negative, is also an imaginary 1. If all these 1s got multiplied by each other, it would still be 1. But because there's a negative there, it's going to be a negative 1. The lead coefficient, because it's negative, is going to tell me something about the end behavior. The degree here, we have x to the second power. We have x all by itself. So we basically have x squared times x, and then times x squared again. That would give us x to the 5th power. So our degree is 5. And why is that important? Because it's odd, telling me my end behavior is going to do opposites. I'm going to go opposites. So based on the lead coefficient and degree. All right. So as x goes up. And I'm not doing the fancy terminology here. I just want you to know what you're saying here. X goes up, Y goes down. How do I know that? I know that because the lead coefficient is negative. So at the end here, gosh, I hope this ends up showing up because I need it for my y-intercept. When I started drawing, it showed up. If it was already there for you, then you have no idea what I'm talking about. This was not here. All right, so that's going to go down, and as x goes down, if you write it with the fancy terminology, good for you. I just want to make sure everybody knows what we're talking about here. As x goes down, aka we go to the left. Are we on mirror images here? Look, watch my pen, not my hands. As the graph goes to the left, my y goes up. I know this because we're odd, so we're going to go opposite. Okay, these are opposite because okay, we are because of odd degree. Okay, so I've got my n behaviors figured out. The y-intercept of this polynomial is I have to take all my y-intercepts and multiply them by each other. So -2 squared times 3 times -1 squared. Well, that's easy. -1 squared is 1. Know you're using your calculator too much if you wrote -1 there. Times 3 times 4, again, positive because it's negative times negative. Then that leading coefficient of negative is going to turn 4 times 3, which is 12, times 1, still 12, times that negative symbol, my y-intercept, aka my constant term, is going to be 12. So -12. I'll treat these like they're 2, 2, 4, 6, 8, 10, 12. And I'll just say that is 0, -12. Okay, x-intercepts, my zeros. So my zeros are +2. Okay, this +2 has a multiplicity of 2, which tells me I'm going to bounce at that 0. At -3, I have a multiplicity of 1, which tells me I'm going to cross. And at +1, I also have a multiplicity of 2, so I'm going to bounce there as well. So what's that look like? Well, -3, -1, 2, 3. Boom. Crossing there at +1, +2. Both of those are going to bounce. So go down, cross at -3. I still need to hit my y-intercept. I need to go back toward the next x-intercept. I need to bounce. Now remember, I'm going to bounce at the next one, so I need to head back in that direction, hit the x-intercept, and then bounce back, and I should be able to connect with my end behavior, and it makes sense. All right? That was so fun. I kind of want to do it again. Oh, lucky me, we get to do it again. I knew it. All right. While I'm erasing, we can talk about having brain fog here because of what the last class did. Okay, leading coefficient and degree of this. Again, we have ones all multiplying by each other. Therefore, 1 times 1 times 1, that's just going to give us a lead coefficient of positive 1. I'm writing the positive because that's the important part of that, not necessarily the number 1, the fact that it's positive. The degree, the number is important there. I have a 2, and then the other x's. Don't forget this x that's by itself. It's very important. I have 1x, 2x's, and then x to the second power, which is like saying x times x times x squared, which gives me x to the fourth power. So my degree is 4, which is even. All right, so based on that, that means that as x, we'll use the fancy terms this time, as x goes up, y, that's just a fancy way of saying y is also going to go up. Why do I know this? I know this because of my positive lead coefficient. Okay, now as x goes down, y also goes up. Why do I know that? Well, I know that because of the degree, because the degree is even. Even degree means that these end behaviors are going to match. We're either going to go up, up, or down, down. In this case, we're going up and up, 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 and away. Y-intercept of this polynomial. Okay, hopefully you were paying attention. You've got -3 and 2 squared, but x being all by itself, that's going to give me a 0. So maybe you skipped on down to the zeros portion here. Okay, this 0 of 0, 0. One of the zeros is 0. So, and that is an x-intercept. It's also a y-intercept. Okay, so if your origin is 0, right? Basically, you're setting the factor x equal to 0. And if x equals 0, well, then x equals 0. And y equals 0 also. All right, so that 0 with a multiplicity of 1. You also have zoomed. I lost some view there. Okay. I have -2 with a multiplicity of 2. And I also have 3 with a multiplicity of 1 based on these factors, right? If I said x minus 3 equals 0, I would have to do 3 on both sides. So x equals 3. That happens a single time because there is just one power there. You don't see it. That means it's to the power of 1. All right, so go ahead and mark it 0, 0. -2, 0, and 1, 2, 3, 0. At -2, we're going to bounce. We said because it's even. We have to head back toward our y/x intercept of the origin. And then we need to head back and cross because that is odd. We're there. All right, synthetic division is what I recommend for these. We didn't really do long division. We did the box method to kind of find our long division. And the good thing about the box method I don't know. I think the box method is tough for long division because it's kind of risky. If it doesn't work out, then you really got to do a lot of inquiry to figure out those middle boxes. So I think something that works is if you have a linear x plus 2 equals 0. So you're dealing with a 0 of -2. That's what you're dividing by, essentially. Okay. Set up your coefficients: 2, -5, -3, -1. I think there's a lot of sirens going off. Hopefully they're not heading here. I think Kamala Harris is coming to town. Might be that. I don't know, man. I don't mess with the politics. Okay. This too, bring it on down. Multiply it by -1. Oh, I put oh, that's going to screw everybody up. That should not say -1. It should say -2. Hopefully you noticed my mistake and you did not put -1 there. You put -2, the 0. 2 times -2 would give us -4. -5 combined with -4, -9. -9 times -2 is positive 18. 18, -3, you get positive 15. 15 times -2, -30. So you have -31. This is our remainder. We're dividing by a single linear polynomial into a third degree. So our answer is it's essentially saying this is 2x squareds, -9 x's, and then a positive 15, the remainder of -31. So how you write your final answer is to say that 2x squared minus 9x plus 15. So what we're saying, actually, it doesn't divide evenly in there. If we went to -2 on the x, we would actually not be at the 0. We would be at -31 over x plus 2. Got to write that part in order to get the full credit. Okay. Last one. And then I got to walk and get some fresh air because you guys are killing me. It's quite unpleasant in here right now. Okay. All right. Luckily, this is in standard form already, but realize that when you have these, so if I solved on both sides, the 0 I'm dividing by, again, I'm recommending using synthetic division here. Use something else. It's fine, but this is the way I'm going to go over it, is synthetic division. So we actually have the correct 0 to divide. X to the third power, the coefficient there is a 1. The second power is -2. This is like saying I have x to the third power minus 2x squared plus 0x. Now, we would never write that normally, but when we're dividing, we need to keep in mind that that term, the 0 term, is there. So we need to actually put the 0 term up there. Okay. Bring your 1 down. 1 times -1 is -1. Combine these and we have -3, -3 times -1, +3, 0 plus 3 is +3, 3 times -1 -3. We actually got one with no remainder. So if you have no remainder, hey, we actually found a 0. This is a 0. This is good news. So we're saying this is 1x squared minus 3x plus 3. So the answer here is x squared minus 3x plus 3. You don't have to write the remainder because there is no remainder. If you wrote the remainder, it wouldn't be wrong. But this tells me, because there is no remainder, if you want to, I wouldn't start with the box method here, but I guess once I find an answer like this, I can check my work with the box method. So what this is saying is that x plus 1 times x squared minus 3x plus 3 is going to be that original polynomial that we started with. X times x squared is x to the third power, which we have. X times x squared times 1 is x squared, negative 3x. So x is negative 3x squared. If I combined those, negative 3 and positive 1, I would get negative 2x squared. That's good news, right? 3 times x is 3x. 1 times negative 3x, negative 3x. Those would cancel off, which is why I don't have, which is why I have a 0 term there. And then 3 times 1 is positive 3. So this can, I'd say the box method can confirm your work, right? But it wouldn't be how I would start the problem with division. All right, good luck on your test. Hopefully whoever was so sick that they made everybody in the hall sick is feeling better. Peace out.